This is class 9 physics, and we have been dealing with the lesson force and laws of motion. In the previous session we have seen about, or we have derived the mathematical formulation of second law of motion, F is equal to ma. In today's session we are going to solve a few numericals. So before solving the numericals, we shall see what are the formulas we are going to use in this session. So we will be using the equations of motion formulas. So the first equation of motion, v minus u is equal to at. Then the third equation of motion, v square minus u square is equal to 2as. Then the third one, s is equal to ut plus half at square. And we will use the Newton's second law of motion formula, F is equal to ma. So this is the first one from NCRT exercise. The truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Find the force acting on it if its mass is 7 metric tons. Hint: 1 metric ton is equal to 1000 kilogram. So what they have done here, they have asked us to find what is the force acting on the mass, which is having a mass of 7 metric tons here. And the truck is starting from rest, okay, and it is rolling. So we need to find what is the acceleration also, and we have to find what is the force also here. So first we'll write the given. So the given is initially the truck is starting from rest, so the initial velocity of the truck u is 0. Then the distance traveled by the truck is 400 meter. Then time taken for the truck to travel down a hill is 20 seconds. We'll see the solution now. So first thing, we need to find what is the acceleration here. So we have the initial velocity, and we have the distance also, and we have the time, and we need to find what is the acceleration. So all these four physical quantities we can find in the second equation of motion, that is s is equal to ut plus half at square. So now we need to substitute the values. So the value of s already I have given. So the value of s is 400 meter. So you can substitute the value of s as 400 meter. And what about u? U is nothing but our initial velocity. So the initial velocity of the truck is 0 because the truck is starting from rest. Okay. Then time is 20 seconds. So anything into 0 is going to be 0 only. So directly I have substituted 0 here. Plus half acceleration we need to find. A we need to find. Then t is 20 seconds. So it is t square. So it will become 20 the whole square. So the next one, so if you solve it, what will happen? We will get the acceleration as a is equal to 2 meter per second square here. Okay. Then the next one, we need to find what is the force here. So they have given the mass as, so force we need to find. So F is equal to ma formula only we are going to use. So your mass is 7 metric tons. So 1 metric ton value is 1000 kilograms. So what we have to do, we have to multiply 7 into 1000. So we will get this as the mass of the truck will be 7000. So now we'll substitute the value here. So force is equal to mass into acceleration. So R F is equal to ma. We know mass value, that is 7000, and the acceleration what we have got is 2 meter per second square. So when we substitute the value, it is 7000 into 2, which will give us 14,000 Newton. So this is going to be the force which is exerted by the truck. Second problem, stone of 1 kilogram is thrown with a velocity of 20 meters per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters. What is the force of friction between the stone and the ice? So again we are asking what is the force here. We need to calculate the force, and we'll see what is the given. So given mass of the stone m is 1 kilogram, then velocity is 20 meter per second, that is going to be the initial velocity. Then after some time what happens, it crosses the frozen surface lake and comes to rest. So what will happen to the final velocity? The final velocity will become 0. So the final velocity v will become 0. The distance is 15 meter. So now we will see the solution. So first we have to find what is the acceleration, and then only we can find what is the force. So force of friction is the opposing force or the force which resists the motion of an object. So here if you see the given, we have mass, initial velocity, final velocity and distance. Okay. So the relationship where we can see final velocity, initial velocity and distance, and also acceleration, because we have to find the force. So we are going to use a third equation of motion. So we all know the third equation of motion, that is v square is equal to u square plus 2as. So when I'm going to substitute the values, for v is the final velocity which is 0, then u square is 20, so 20 into 20 plus 2 acceleration we need to find, and then 50 is the distance here. Okay, and then always check whether all the physical quantities are in their SI units. So when we solve and simplify it, we'll get the acceleration as a is equal to minus 4 meter per second square. So the negative sign tells that the body is retarding, that is the velocity of the body is reducing, because initially it is at one velocity, one speed, and then gradually it comes to rest. So what happens here, the acceleration will also be negative. So when the velocity is negative, we call that acceleration to be retardation. So that's the reason we have negative sign over here. So now what is the next thing? We need to find what is the force here. Okay, so we're going to use the Newton's second law formula here. So Newton's second law formula, we know F is equal to ma, mass of the stone is 1 kilogram, and acceleration we have found, that is minus 4. So the total force will be minus 4 Newton. So the negative sign indicates that the force is acting the opposite direction of the motion of the stone here. Third problem. An automobile vehicle has a mass of 1500 kg. What must be the force between the vehicle and road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? So it's a very simple formula. It's a just direct substitution. So mass they have given and acceleration they have given. So we have to just find what is the force. So first we'll see the given. So given is mass is 1500 kilograms. So mass is in its SI unit only. Then final velocity here, what happens? It is 0 here. Okay, it has been stopped. So it is stopping, it is moving, and then it is stopped. So final velocity is also 0. Then acceleration is minus 1.7 meter per second square, because in the question they have given it is negative acceleration. So A is equal to minus 1.7 meter per second square. So we'll see the solution, just direct substitution from Newton's second law of motion. We know that F is equal to ma. So mass value is 1500 and into 1.7, that is the acceleration. So when you multiply these two values, you will get the forces minus 2550 Newton. So SI unit of force is Newton. or else you can write as kilogram meter per second square also. And again, the negative sign, what does it indicate? It is indicating that the force is in the opposite direction of the motion of the object. In today's session, we have solved few numericals. In the next session, we'll see the very interesting law, Newton's third law of motion, and its application. Thank you, children.